Hello, everyone. Welcome to the A4Q World Congress. My name is Agustina, and I will be hosting this session tonight. I am very happy tonight to announce that I'm here with Raluca Vartic, our speaker. Hi, Raluca. How are you?
Hello. Hi, Agustina. I'm doing great. Thank you. How are you?
Thank you for being with us tonight. So, Raluca is engineering manager at Macadamian Technologies, and she's going to be speaking today about test automation as a team responsibility. So, for everyone who is watching, we are live at this moment. So, if you have any questions or any comments, you can write on any of the social media that you're watching us through, and we will get the questions to Raluca once we have the time. So so now we are ready to start. Raluca, I leave you with the stage, and if there's any question, you can write anything.
Great. Thank you so much. Hello, everyone, and welcome to this session. My presentation is about test automation in the context of agile teams. Have you ever been on a project and thought, the way we're testing right now just won't scale? Let me tell you a story. I once joined this amazing team. They were working on a product to help patients manage a serious health condition. After just a few months, they were ready to deploy the solution to doctors and patients. But first, we had to figure out how to perform regression testing in less than 1 day. The plan was to continue to release a new version of the application every other week. We had a problem, however. The team had written more than 1,000 manual test cases. There was no way we could execute all those test cases in less than 1 day. Something had to change. This is a common scenario on agile teams. These days, applications release new features frequently, and these releases require a lot of regression testing. When we are doing regression manually, it either takes a long time or the testing coverage is limited. Even when we have scripts helping us verify the functionality, issues with how the testing effort scales are common. Test automation can come to our rescue. Automated tests allow us to verify, without any human intervention, that a product works as intended. As the software evolves, we can use these tests to quickly check that the product continues to work as intended. I've been helping teams automate testing for a few years now. Last winter, I started writing down what I had been learning in the process. As I was going through my rough notes, I realized that there was one element that would influence a team's success in adopting automation more than all the others. So, whether you are starting automation from scratch or trying to improve an existing regression process, there is one thing you can do to increase the chances of test automation working well for your teams. Keep the accountability for the test results within the team. You see, most of the issues with streamlining testing come from a handful of misconceptions about test automation. These are the 4 main ones I have come across. The first myth is that we do not want to slow down a busy team. The second myth is that test automation will become a maintenance nightmare. The third myth is that automation is the responsibility of a specialized team or just a few individuals specifically assigned to do testing or regression or designated as the quality assurance team or test automation engineers. And finally, the last myth that I will present today is that robots will take care of all testing in the future and we will become obsolete in our jobs. I am really curious about your experiences. It's really difficult to interact with an audience live, but I'm looking forward to the discussions after the presentation. So please let us know in the comments what are the main challenges you have encountered when trying to adopt test automation. I have heard the 4 myths that I decided to focus on many times on my journey. I will show you how we can look past them so that we can hear more test automation success stories. The first myth is that writing tests will slow us down. You may have heard something like, the core teams need to maintain a certain velocity and they just can't be bothered to automate their tests. This belief can lead to a complete lack of tests, especially if the budget is the most important constraint. If the schedule is the most critical constraint, the fear of reduced velocity could lead to setting up a dedicated team, either for testing new releases or for all the test automation activities. So, what this myth is basically saying is that test automation has an impact that we just cannot take either on the budget or on the schedule. Now, let's take a step back and look at the impact that a serious development bug has depending on when it is caught. To make this more real, let's say that we are working on a COVID-19 screener app. Before going to the office as an academian employee, I have to fill out a survey. As a user of this survey, I have to enter some personal information, then answer questions about my symptoms, my travel, and my recent contacts. At the end, based on my responses, I get a result. In this case, I get a pass and a green screen, so I'm allowed to go to the office. Let's imagine that this was the application that we were working on, and this was the functionality that we had at the end of last sprint. We are now starting a new sprint. We have to add a new page where the users can review and change their answers before submitting them. First, let's look at the impact of a regression caught during the sprint by the automation framework. Let me translate what I'm trying to illustrate here. It is common practice to have a main development branch that only includes stable, fully functional features. That's the horizontal line at the top called develop. Completing a new feature may require several code changes, so we work on a separate branch. The second horizontal line is a feature branch for the review page we're implementing. A complex feature requires several code changes. For example, in our case, we would have to implement the layout for the new page, insert it into the navigation flow, and also implement all the actions for the buttons on the page. If, and now this is a very big if, but if we have a set of tests that are consistently passing, that are executing fast enough to be run for every code change, and if those tests caught this regression, then we can see that the team is alerted as soon as something is wrong. There were some big assumptions here. I don't want to make it sound like it's trivial to have tests that execute in a reasonable amount of time. I will talk about how this can be achieved a little bit later. For now, assuming this is possible, we can see that the impact is minimal. The issue can be fixed immediately before it becomes a defect by the team members already working on the related tasks. There is no context switching. The defect is directly associated with one code change. So the root cause should be easy to find and easy to fix. Alternatively, let's see what happens when issues are only caught later by a regression team testing a new release candidate build. Ideally, they would want to test the build, confirm that there are no issues, and release it to the users. The release branch is cut at the end of a sprint. We can assume that the teams have completed several new features. Because tests are only executed by the regression team, if there are failures caused by any of the code changes made last sprint, this is the first time we find out about them. Now, when the changes are already part of our release candidate. For each test that is failing, the team has to determine the root cause. If the application is not behaving as expected, they will open defects. If the tests are not up to date, the team will need to create some tickets for maintenance. Any new defects have to be triaged at a minimum to determine whether any of them would be a blocker for the release. In the event that at least one issue is a blocker, it will require a hotfix, which might need to cause the entire regression process to restart. So let's summarize the impact. There is a dedicated team performing regression testing. An additional team has an impact on cost. Triaging bugs takes time for product owners and possibly for other team members. Isolating the root cause of a test failure can be really tricky when we are dealing with a lot of changes. This troubleshooting also has an impact on time. Resolving bugs and ensuring that none of the old or new functionality is impacted also takes time. Bugs caught late in the process are a lot more expensive to fix. And these bugs have an impact on the team whose velocity we were initially trying to protect. There is, of course, also an impact on quality. We could be releasing a version of the application with severe known issues that might impact real users. The belief that test automation cannot be afforded often comes from looking at the initial cost of setting up an automation framework, maybe also the cost of maintaining it. But this belief is not considering the cost of bugs. This belief is not considering the huge effort required when we are performing manual regression testing on a continuously evolving application. Translating into numbers the impact on quality and user satisfaction is not easy, but this impact also has to be considered. When my team members tell me they are too busy to write unit tests or integration tests, I talk about the risk of somehow in the future breaking the logic that we are so carefully building now and not even becoming aware of it until bugs are reported. I see teams rushing to get features done without thinking about how to make applications testable and paying the price later. I see this all the time. Stakeholders on agile teams need to know this. On long-running projects with frequent releases, we cannot afford not to invest in test automation. The second myth is that tests are brittle and their maintenance can become a nightmare. You can also recognize this in the form of fear that tests will need to be continuously updated. The concern is that maintenance will cost too much time and money. The concept of the testing pyramid has existed for more than a decade. However, for many projects, when a decision is made to invest in test automation, the solution is to automate all the existing manual tests. As a result, many teams still automate end-to-end tests only. This presents several problems. Higher level tests involving browsers or devices take a long time to execute. End-to-end tests could also fail for a number of different reasons, including factors that have nothing to do with the product we're testing. For example, browser updates, different screen resolutions, or intermittent network conditions. The maintenance of these end-to-end tests can be costly. Even if regressions are being caught by the automation framework, if the framework consists of a lot of end-to-end tests, it may be difficult for teams to react quickly. Because tests take a long time to execute, they are not executed frequently. And when they are executed, there are always failures. There is just too much noise to be able to zero in on the actual issue. The solution is to move away from using only end-to-end tests. Instead, teams can develop an automation strategy that heavily relies on more granular tests. Let's see an example. We're now back to our COVID-19 screener. For now, let's focus on this page where the user has to enter some information. We are performing some validation on these fields. For example, if we enter an invalid email address, the field is highlighted and we cannot go to the next step. Let's focus on this small portion of testing. Is the text in our email field a valid email address? There are many examples that could be tested as valid and invalid inputs for the email field. As you can imagine, testing all these examples manually can be quite tedious. Testing these examples automatically by just mimicking manual testing steps is an improvement, but it's still not great. Launching a website or a mobile app, then navigating to this page, entering user input, this takes time and resources. This test, done as an end-to-end test, would take tens of seconds, maybe even a few minutes. This is just one field. We had 4 or 5 on that screen. End-to-end tests, validating all of them, would likely take several minutes. This is still just one page in a very simple application. You can easily see how the execution time will increase as we add more tests and as the application evolves. So what do we do? Well, there is probably a method in the front-end code that performs this validation. It takes a text as an input, and it returns true if the validation passes, and false if our input is not a valid email address. That method could be an excellent candidate for a unit test, a very granular test. We could probably provide tens of checked examples of both valid and invalid emails and really exercise the boundary conditions in the unit tests we design for the email validation method. We could also write some granular tests for the UI control, checking that it behaves as expected in error states. Now let's see an example of a unit test on the backend code. If you remember our screening scenario, eventually, after the user has answered all the questions, there will be a result. The employee is either allowed to go to the office or not. Testing whether we get the correct result in the UI would take several minutes. We have to navigate through all pages, enter the user information, then one by one select all the different combinations for symptoms, travel, contacts, and then check that the result is appropriate. But we know that the server will decide the result based on the survey data that we send. In the backend code, there is some logic deciding whether the result should be pass or do not enter. That method, which is taking in survey data as an input and providing the screening result, that is the method we should be testing, instead of implementing a set of complex UI tests. That method is a great candidate for unit tests to ensure that our business logic remains reliable even if the application's UI changes. If we have to add a new screen, allowing the user to review their answers before submitting them, these unit tests don't have to change at all. Instead, if all we had was end-to-end tests, all those tests will potentially have to be updated to include the new screen. You see, by writing the tests at a more granular level, we have reduced the execution time from minutes to milliseconds. We also have tests that need less maintenance when the application changes. We've seen a few examples of tests at the most granular level. We are now moving one level higher in the pyramid. We look at API tests. Here, we are no longer testing just one method in isolation. API testing requires the server code to be deployed. We are making requests over the network. So these tests are slower than unit tests, but still a lot faster than end-to-end tests. You see, because we have good coverage from the unit tests, we can have confidence that the logic for determining the result is well tested. Therefore, we can write fewer tests here. We only need one test for checking that when submitting valid responses, we get the result back correctly. So we can get away with only a handful of API tests, one for valid survey information and some error scenarios, for example, for authentication errors or bad requests. As a test automation engineer testing the API, if I was on a separate team from the authors of the unit tests, I may not have visibility over what is being tested at the more granular levels. I might try to duplicate some of those tests here. As a QA specialist siloed from the unit test work, I might try out all those scenarios manually. That would take a lot of time and, again, be a duplication of effort. But because I have no visibility over the tests, I don't trust them. I might not even know about them. On the other hand, if we are all part of one team and we all have visibility over what is being tested at every level, we can develop strategies to reduce the execution time and continuously improve our tests. If we can think of some examples that are not already covered by unit tests, we can add them ourselves, or we can bring it up with the team. Finally, let's look at the top level of the pyramid, the UI or the end-to-end tests. It would be nice to have one test here on a web UI or mobile device just to make sure that everything integrates well and the user can complete an entire flow. We can have a test to launch the application, walk through all the screens, enter information on every page, all the way to the end. Because we are confident in our API and tests and our unit tests, we can get away with maybe just one end-to-end test here. We have good coverage already. This helps keep the overall execution time low. Products automating only end-to-end tests are common. Some of you may have had negative experiences in the past where the maintenance of the automation framework was indeed a nightmare. But don't let that discourage you from automating your tests. We have seen here that when everyone is on the same team, and by everyone I mean team members developing the code, the unit tests, the API tests, the end-to-end tests, as well as team member writing and executing the manual tests, when we're all working together, it's easier to communicate, to optimize test strategies, to write stable tests, and to keep the execution times low. The third myth is not my responsibility. This can take many forms. Perhaps developers don't want anything to do with testing. They may feel like it's not a good use of their talent. Or, quite the opposite, test automation engineers want to keep team members away from automation code. They may consider testing a highly specialized craft for which they take pride and feel like anyone else contributing to this code will just mess it up. In other cases, accountability for regression is delegated to an entirely separate team, and the core team is liberating from having to worry about regression. In order to illustrate how damaging such attitudes can be to a team's performance, I will compare two scenarios. In the first scenario, the core team has no accountability for test failures, while in the second one, the entire team collaborates in defining and refining the test plan. My first real assignment in the world of testing was to lead the regression team. We started every sprint with a set of automated tests, and every sprint we would execute them. There would be failures, many failures. Our responsibility was to investigate each failure and figure out if it was a serious issue that could potentially block a release. Most of our time was spent troubleshooting and updating poorly maintained tests. While my team was busy with regression activities, 4 other teams were busy adding new functionality to the product we were testing. Every sprint, the story would be very similar. We started with a large number of tests to investigate. We would race to fix as many as possible, never quite reaching that moment when we see all the plans executing with 0 failures. Never, in almost 2 years. The core teams never became aware of the impact their changes had on automation. There was no immediate opportunity to learn how to prevent similar test failures in the future. And don't get me wrong, we had successful releases. There was no way regression for such a complex product could have been done more than 20 times in a year without automated tests. However, even though leading a regression team was my responsibility, I was coming to realize that the regression team existing in the first place was shifting accountability for the test results and quality away from the teams developing the product. If the agile teams are siloed from the development and execution of the tests, bugs are caught late, developers continuously break the tests without even knowing, and we repeat this every sprint. Life on a project where the entire team collaborates in defining and refining the test plan is a little different. Team members reflect on the best approach for testing a new user story. As we have seen in the COVID-19 screener app, the team can decide what can be tested at a granular level by unit tests and what will need to be covered by higher level tests. Team members test their code as it is being developed, and those tests are automated. Failures that are due to changing features are caught and fixed early within the same team. The test suite evolves at the same time as the product. The maintenance cost is also minimized. There can be no obsolete tests because we are continuously executing them, and failures are evaluated and addressed immediately. The team members are free to contribute to both the product code and the automation code. When we are developing new features, it is more efficient for existing tests to be adjusted at the same time. The team is aware of the testing efforts, and everyone can contribute to improve the process. It is easier to maintain test suites with 0 failures. This allows us to react quickly when failures do occur. And finally, code is expected to be testable. Clear patterns are set in place from planning stages in order to support the automation effort. The patterns are understood, followed, and continuously refined, with input from all team members. We have seen that on teams where we own the test results, we are motivated to collaborate, to learn, to continuously improve the way we test, and in the process, we prevent bugs. The fourth and final myth is I will lose my job to robots. I have met both developers and testers who are reluctant to consider or adopt test automation. Change is difficult, and the fear is real. It can result in pushback. The result could also be an intimidating number of manual tests, which are impossible to keep up to date. Executing all those tests manually would take an army of testers with a lot of patience. Computers are helping us test products today. Also, new tools are becoming available, some employing machine learning or artificial intelligence to assist with testing. In order to keep up with these advancements, sometimes as members of agile teams, we need to develop new superpowers. However, not everything can or should be tested without human intervention. I believe there will always be a need for exploratory testing, usability testing, and problem solving. We can let automation take care of the boring, repeatable part of our work. Automation is complementing, not completely replacing manual testing and human judgment. These days, features are being developed very quickly, products are becoming more complex and running on more and more platforms. Testing, at the pace software is evolving, is becoming really difficult, so I, for one, welcome any help I can get. By writing programs for the repeatable tests, we gain more time for activities that still require human creativity and judgment. Time to wrap things up. We have covered a lot of ground. I wanted to have all the learning outcomes summarized on one image, so feel free to take a screenshot for future reference. We talked about the fear of reduced velocity, negative experiences with automation due to frameworks using only end-to-end tests, the lack of accountability, and the fear of becoming obsolete in our jobs. We analyzed each of these beliefs, and I'm hoping I'm leaving you with some practical strategies to bust these myths. When adopting automation as a team responsibility, tests can become worthy allies. They help us defend against human errors. They make it possible to get features to the users quickly. We went over what I think are the most common myths standing in the way of test automation. So, next time you come across one of these myths, you can become the test automation mythbuster. Thank you. And here is my contact information if you would like to connect.
Thank you, Raluca, so much for this amazing presentation. It was really interesting and really informative. So let's see if we have some questions. So anyone, if you have some questions, some comment for the presentation, you can write it down and we will get it to Raluca. I have one question. What would you believe is the biggest challenge for moving from manual testing to automated testing?
So I can think of two scenarios. One is when we are building a new product from scratch, and the other is when we have a product already and we want to automate tests. So I will cover both.
Okay.
When we are building everything from scratch, I think there is a mindset barrier, maybe just being comfortable and figuring out when is the right time to start the automation process, and getting the cadence, getting all the team used to the patterns. So there's that moment when the team is forming and deciding how they work. And I think it's really important to start with the right mindset. And in the case of an existing product, which is maybe very complex, we are in a situation where we need to catch up. So it's almost like catching up, like writing automated tests for everything that already exists. It can almost be handled as a separate project. And it's really important to involve the team who is developing the product, if they are continuing to add features, to make sure that they start automating the tests once the patterns are set, so that this becomes a habit. And when we are caught up, we are ready to go full speed with these new processes.
Okay, thank you. We have a question from Andrea. He says, what is your opinion about using specification by example for testing?
Specification by example. I'm trying to understand exactly what
Yeah,
she
I'm
could
not sure
mean.
also about the question, Andrea. Maybe you can clarify if you write it.
So I'm thinking maybe trying to answer this if we don't get more details.
We have another question while we wait until Andrea writes us. It's George Sakultanon says, how do the earlier testing and catch the bugs in time when the development team is late in the sprint with their deliverable?
How do the earlier testing and how do we manage to catch the bugs in time when the dev
Yeah,
is late in the
how to
sprint?
test earlier and catch
Yeah.
the bugs in
Okay,
time
I got
before.
this, I think. So I think this comes with the assumption that testing comes after development. What I'm saying is, no, actually, if you don't have a test that is passing, then how can we call that feature done? So having a test and having it execute and pass without failures should be, in my opinion, part of the definition of done for a story, right? So it's not something that we always need to catch up, but it's rather something we think about in advance when estimating the tasks. We can write the tests a little bit in advance, knowing that the feature will come. We can foresee what will need to be tested, and it's already at the same time, and we can work on the same branch so that it's no longer an afterthought or an activity that is happening after. It's part of planning, it's part of the work. It happens at the same time as development, and both are required in order to call something done.
Okay, perfect. And Andrea, thank you. Andrea wrote back. She says, writing specific steps in actual words, like check if login button works. It is mostly used with Cucumber, I think. And the first question, what's your opinion about using these specifications for testing?
Yeah, so I think there is value, and there is a fine art of deciding how specific we want to get, because we do, especially if we rely very much on these high level tests. So we do need them. We need integration tests, but ideally we don't want them to cover every detail. So saying something, check if login button works, I think is a good way of approaching things when the audience for your tests is the team who is familiar with the application itself. Whereas if you were really detail oriented and if you were writing only manual tests, you could be tempted to write very detailed steps like, go to this page, click on this button. This is how you check if it works. You click once, you expect the button to behave this way when you hover, this way when you click, this way when you dismiss when the click is finished. So it could get into a lot of details, and that is really hard to maintain. And because these tests are repeated all the time, really the people executing them would probably be familiar with the expectations. And there's not a lot of value in providing every little detail in the test itself. So having it a bit higher level would make a lot of sense. Now, where we could run into issues is if we have to hand this over to somebody who is completely new to the product, then there may be a knowledge sharing session that needs to happen to make sure that the expectations are aligned and we are not losing some of the testing that we were done that was not specifically written down in very intricate details. So I hope this answers the question.
Okay, perfect. I think so. Thank you very much. So that's all the questions we have for now, and we are right in time. Thank you so much, Raluca, for your time. Thank you,
Thank
everyone
you.
who's watching. Please keep in mind that in around 15 minutes, we will start with our online social event. We are celebrating Oktoberfest, so you can join us for free. We have some music, some games. So please check our social media and you check where you can join. And wait, we have a new question coming. Okay, Martin, specification by example is capturing and illustrating requirements using realistic examples instead of abstract statements. Okay.
Yeah, so again, I think this applies more to manual testing and how we phrase those tests. When we automate those steps, we have no choice really but to have real examples. So I think this is a good approach to think of the step-by-step flow for test cases, but also keep in mind how the collection of test cases will grow as we add more and more tests, and make sure that is maintainable and sustainable for your team.
Okay, perfect. Okay, now I think that's the last one. Okay, again, thank you so much, Raluca. Will you be around? Will you stay around for the Oktoberfest?
My pleasure. I will try to connect, maybe not the entire thing, but I will drop in for sure.
Okay, perfect. So if anyone has questions for Raluca, you can find her. Yes, it will be hosted in Gathered Town. You can see on our social media and you can find all the information for joining the event. And thank you so much and have
My
a
pleasure.
beautiful evening. Bye
Thank
bye.
you. Bye bye.
This 27th of October, we wait for you to celebrate Oktoberfest in our Gather Town. For sure, it will be a very entertaining event with live music, with A4Q staff, and of course, all of you. Don't miss our A4Q Oktoberfest. It will be very fun. Prost!